Alright guys, so hope everyone's doing good over their quote-unquote break and everyone's been doing okay. Everyone's staying home and staying safe. So real quick, I know I haven't heard from you in a minute. I haven't made a video in a few days, so I wanted to make this to kind of help y'all out, and because I know that a lot of you had been messaging Miss Cooper and saying that you've been having some trouble with this, and I wanted to address some of those concerns and just go over a little bit of what you were supposed to do today. And what I'm actually going to do is I'm going to go over this top row right here from your homework that you were supposed to do, and then I'm going to go over one of the problems on the other sheet over here. I'm actually going to do number 8 on this one. And so what this is asking us to do, it says fill in the blank with the blanks with the predicted products from the adjacent reactants. Circle the products that precipitate out or form a solid, or the ones that are insoluble. So something that a lot of you should have seen in your PowerPoint that I had linked, or even the sheet that I had linked on the Google Doc for today, was something that looked like this. These are your solubility rules, and these are things that you are going to need to familiarize yourself with. This is basically your key when you're doing problems like this. So if you don't have this, you need to have this ready when you're doing work or quizzes or something like that. You need to be familiar with these, or you need to have them pulled up on your computer or your phone or somewhere else. And so with that being said, let's get into the first one. So the first one, FeCl3. I'm sorry for the lighting, but it says FeCl3. This is the reactant, and this is the other reactant that it's going to react with. So FeCl3 plus NaOH. So this looks like to me to be a double displacement reaction, which should be reviewed from last unit. So I'm going to go through these a little quick, but I'm going to still go through the steps because this should be reviewed for most of you. So let's go ahead and find our charges on this one first. So Fe, what is our charge on Fe? Well, we don't know because this is a transition metal. This is an unknown charge, so we can look at Cl. What is our charge on Cl? Now that's actually a known one. So what I'm going to say is we know that Cl has a -1 charge, so I'm going to write that right here. Cl -1. But what's our charge on Fe? Well, we can also tell that from this. There's a 3 right here. So since that's there, and we know that the charge on chlorine is -1, we know that the charge on Fe is going to be +3. Okay, so, and then we're going to come over here. NaOH, what are the charge on each of these? So Na and OH. And now you can figure both of these out from looking at the periodic table and your polyatomic sheet, which you should remember OH is -1 and Na is +1. So this is a 1-to-1. There's no numbers, there's no subscripts, so this is a 1-to-1. So double displacement reaction, we're going to put Fe with OH. This is predicting the product from last unit. This should be reviewed. So I'm going to write FeOH as my first product. And then what do I need with that, though? Right, so like Fe has a +3 charge. So this OH right here is going to need a 3. So that's my first product, and my second product is going to be NaCl. NaCl. And now it's asking you to circle the product that is insoluble. So if we come up here and we look at our solubility rules, we have FeOH3 and NaCl. So let's start with this top one first. FeOH. Let's see if we can find anything about either of those up here. And as I'm looking through this, I don't see anything about Fe, but this one at the bottom down here says hydroxides are insoluble compounds. But the only exception with that is when it contains an alkali metal or a Ba2+. Is iron either of those? Is iron an alkali metal? Is iron in group 1? No, it's not. Iron is not in group 1, nor is it Ba2+. So since this one has a hydroxide, we know that this is going to be an insoluble compound. So I'm going to come down here and I'm just going to circle it. What about NaCl? Let's look at this one now. Okay, so soluble compounds. Right away, the very first one up here says compounds containing alkali metals, alkali metal ions, Li plus and Na plus, are soluble. And it also says that halides, which includes Cl minus, which both of which we have on our product, are always going to be soluble, so we know that we can leave that one uncircled. All right, so looks like we're done with that problem. So let's move on to the next one, or the next part of this one. So this one is going to be FeCl3 plus Na3PO4. Again, let's go ahead and write our charges for this one. This is the same start as last time with the Na, so we know that Na is going to have a +1 charge. So I'm just going to write Na plus. What about PO4 though? What kind of charge does that one have? Well, there's this 3 right here, which should be pretty telling that the charge on PO4 is going to be -3. So we've got our charges on this reactant and this reactant. So now we just need to get our product. So our product is going to be Fe and PO4. But wait, Fe has a +3 charge and PO4 has a -3 charge. So what do you think is going to happen when we write the product? Exactly, the 3's are going to cancel out. I'm like Dora right now, just waiting on you to answer. Waiting on nobody to answer me. Anyway, so FePO4 is going to be our first product. And then we have sodium and chlorine. So this is actually going to be the same as our last one. It's going to have NaCl. It's going to be our next product. My computer is turned off. Okay. So again, let's go ahead and look at our solubility rules. We remember that there's nothing on our solubility rules about iron. So let's look for a phosphate, a PO4 -3. So what I'm seeing is this one down here. There's a thing about PO4 3- right here. It says that phosphates are insoluble compounds, but there's an exception that says compounds containing alkali metal ions and the ammonium ion are the soluble exceptions. But let me ask you, is iron an alkali metal? Is iron in group 1? No. Or is iron ammonium? No, it is not. Iron is not ammonium. So we can go ahead and circle this one because we know that this one is going to be insoluble. And same as last time, same product, NaCl, NaCl, we're going to leave that one uncircled. So that's all for that one. Now let's come up to this one, Ki. So this one's a 1. This one looks to be a 1-to-1. There's no numbers, so what's the charge on potassium? It's +1, right? Yes. What about on iodine? Well, since this is a 1-to-1, we know that this one is going to have a minus charge, a -1 charge. All right, so that should be pretty easy. So what I would do now, we've got our first one over here and our second one over here that we're going to switch with. So it's going to be FeI, iron iodide. But what are we missing? Again, we got to remember to bring our 3 down. This is just like what we did last unit. This is exactly the same. This is just predicting the product. All right, and for our last one, we've got potassium with a +1 charge and chlorine with a -1 charge. So this is going to be KCl. Okay, so also feel free to pause at any point or rewind if you need to take these steps a little slower. So let's look at FeI3. Let's look up at our solubility rules, see if we can find anything about that. So again, there's nothing up here about iron. It doesn't say anything about Fe. But what about I? Can you spot anything up here about I? Yes, I can. There's one right here. It's talking about the halides. So there's an I- right there, and it says this one is actually going to be a soluble compound, but there are exceptions. It says halides of Ag+, Hg2, 2+, and Pb, 2+. None of those are iron. Is that iron? No. Is Hg2, 2+ iron? No. Is Pb 2+ iron? No, it is not. So we know that this one is going to be a soluble compound. So that means we're not going to circle it. And KCl. So compounds contain, this is just like NaCl. So there's Na and then K right there and a Cl down here. Both of these are soluble. Compounds containing alkali metals such as K are soluble, and halides containing Cl are soluble. So this one's doubly soluble. So we're going to leave both of those alone. So we're done with this part. And for our last one, we've got Na and CO3, Na2CO3. So what is my charge on Na going to be? It's going to be +1. What about on CO3? Well, there's a 2 right here, isn't there? Yes, there's a 2. So what does that mean? What does that mean for this carbonate? Yes, it means there's going to be a -2 charge on it, because that 2 had to come from somewhere. And remember your polyatomics. CO3 is a polyatomic, so make sure you remember that. All right, so last thing we need to do is switch up these products. So Fe is going to go with CO3. So I'm going to write that right here. FeCO3. But we've got to remember our charges. What is our charge on Fe? It's 3. And what is our charge on CO3? It's 2. So since the 2 is on the CO3 up here, we need to cross that down, don't we? So the 2 is going to go right here, and then we're going to put parentheses, and then a 3, because this 3 is coming from the +3 charge on the iron. You see, it's right up here, and then it's going to transfer that charge to the carbonate. So Fe2CO3, 3 is going to be our product. I know it's a lot, but just remember your charges, and it's should be pretty, you should get this pretty easily. And now our last thing, we have Na and Cl, same thing we did in the first two. So I'm just going to write NaCl. All right, and now we're going to look at our solubility rules. Let's look at Fe2CO3 first. So we already know there's nothing up here about Fe. What about CO3 2-? Do you see anything about up here that might help us? Yeah. Under here, it says carbonates, or CO3 2-, are insoluble compounds, except when they are attached to an alkali metal or an ammonium ion. Is iron either of those things? Is iron an alkali metal? No. Iron is also not ammonium, so we know that this one, since carbonates are insoluble compounds, CO3 2- is an insoluble compound, we know that we can come down here and go ahead and circle this. And we know from our first two problems that NaCl is a soluble compound, so we're going to leave that one. All right, so it looks like we're done with that part. So the last thing I wanted to do is just a little review for this. Don't pay attention to this. My dad was actually a chemistry major, and he wanted to try some of the work I was giving y'all last night, so this is his work. Notice there's a lot of scratched out stuff. All right, so we're going to look at this NaI plus PbNO3 All right, so first thing I want to do is note my charges. So the charge on Na, what's the charge on sodium? Na. It's +1. What about iodine? It's -1. You should know this from looking at your periodic table and from studying it for the past like 3 units. Okay, Pb is kind of in a weird place, but we know that the charge on nitrate is NO3 is -1 from our polyatomic sheets. Again, if you need to reference those, go ahead and pull those up. And so Pb, what about that? This is a bit of a weird metal right here, but NO3 we know has a -1 charge, but there's a 2 right here outside the NO3, so we know that that had to come from the Pb. So Pb is going to have a +2 charge. Since it's still a metal, it's going to have a positive charge. All right, so now that we have our charges, we're going to go ahead and swap these reactants with each other. So the Na is going to go with the NO3, and it's going to make sodium nitrate. So over here, I'm going to come and I'm going to put my blank right here. NaNO3, and this is a 1-to-1 because the charge on sodium is +1 and the charge on nitrate is -1. So we don't need to write anything here or here. We don't need any additional subscripts. I'm going to write my blank right here also. Plus blank. And then our final product is going to be, we're left with, the only 2 we have left are Pb and I. So I'm going to write lead iodide, Pb, I, but what's the charge on Pb? It's 2+, so just like the nitrate got a 2, the iodide is also going to get a 2 since they have the same charge. Iodide had a -1 charge, and so did nitrate. Nitrate got a 2, iodide also gets a 2. So I'm going to write my other blank over here. And so the next thing we need to do that the problem is asking us is balance. So got to balance my metals first, then my nonmetals. So Na, Pb, those are my metals. Now I'm going to do my nonmetal, I, and then my polyatomic, NO3. All right, let me fix my pencil real quick. Okay, then I'm going to come over to the product side and do the same thing. Let's see, Na, Pb, I, and NO3. All right, so on my reactant side, how many sodiums do I have? 1. How many leads do I have? How many Pbs do I have? 1. How many iodides do I have right here? 1. And how many nitrates do I have right here? I've got 2. You see this 2 outside the parentheses, so I know I have a 2 there. Same thing on the product side. How many sodiums do I have? 1. How many leads do I have? 1. How many iodides do I have? I've got 2 iodides. And how many nitrates? How many NO3s? 1. All right, so now we balance. Sodiums, they appear to be balanced. Leads, there's 1 on each side, so those are balanced. Iodide, there's 1 on the reactant side and 2 on the product side. So I know that I'm going to need to go ahead and put a 2 right here, but now I've changed my number of sodiums to 2. And I've also changed my number of iodides to 2. So what do I need to do now? I need to come back and rebalance this sodium before I can move on. So I'm going to put a 2 right here also. So there's 2 sodiums, but now I've created 2 nitrates. But now, look, we're all balanced now though. So there needs to be a 2 in front of the sodium iodide and a 2 in front of the sodium nitrate. So the last thing we need to do is categorize each of these compounds as soluble or aqueous or insoluble, also known as solid. So one last time, I'm going to pull up my solubility rules. So NaI. So if we're looking at our solubility rules, is there anything about Na? Yes, up here. Compounds containing alkali metals, such as Na, are soluble. So I'm going to go ahead up here, and I'm going to write AQ right here to denote that this is a, let me make that a little more clear. AQ to denote that this is a soluble compound. PbNO3 Is there anything up here about Pb? I see something right here about Pb's, but there's not a halide attached to it. So what I'm going to do, there is a thing about nitrates though. So our product right here was PbNO3 So if I'm looking up here, it says that nitrates are soluble compounds, and there are no exceptions to that rule. So if you see a nitrate, which we have right here, NO3, we know that this is going to be a soluble compound also. So I'm also going to put an AQ right there. All right, and NaNO3. We know that compounds containing Na are soluble, and we just said that compounds containing NO3 are soluble, so this one is a double soluble. So we know right away that this one is going to be aqueous. Aqueous just means it's in solution. That's what that term means. So it means that something is soluble, basically. And our last one, PbI2. So let's see. Oh, let's look at halides right here. There's one about Pb and I. So it says that halides, which are compounds that contain Cl, Br, or I, are soluble. So this one contains an I. So you would think that this one would be soluble, but there are exceptions to this rule, as you can see on this side of the table. So halides containing silver, mercury, or lead, Pb, are insoluble. They are the exceptions to the rule. So since this one contains an I and a Pb, this one is going to be one of the insoluble exceptions. So what that means is that this is going to be solid, and I'm going to write an S right there. So I hope this helped anybody that was struggling. I wanted to go through this since I hadn't made a video in a few days, and a lot of you seem to be struggling on this, and I know this is hard stuff, but a lot of it is review. So I would urge all of you who missed the opportunity yesterday to go back and try these, since this will be important to the unit, because if you don't know these solubility rules, then it's going to be difficult going forward, because these are going to be a big part of the unit. But the good thing is they're right here for you if you need them, so I would urge you to use them. And yeah, hope you all have a good rest of your night or day whenever you're watching this, and I will talk to you later.